Okay, let's begin the lecture, right? So this lecture will be a lot of my lecture will be in this format that you will learn together a bit. Look together, you will learn both concepts and the code together. That means you need to you probably if you learn this on the laptop on the desktop, you probably need to have kind of like separated one part as video maybe and to follow the pace and another one for coding. If you watch this from iPad, you probably have it will be a little bit difficult to code there, right? Because and then that means you have to kind of follow through the code to run the code later on to learn this. For now, if you are in that situations, maybe it's best to watch and ask questions if you have that. What I'm going to show you is for today is how to use R, right? So that means including the software itself, the R tutorial, the concept of R, comparing to say Python, if you already have learned that, or C, which you learned it in your first year. Okay. Have any but has any of you had any experience with scripting language like R before or Python? I think many of you may have learned that Python already. Many schools nowadays teach Python as the basic programming courses. Okay, so have any of you know R or Python already? Okay, one of you learn R a bit in Mathematics 6. How about the others? Pythons are fine. Actually, any languages would be fine. You learn a C already. So these R things should be easy. I learned it myself about the years 2008, I think. Yeah, okay. Some Python, no R experience. That's fine. Totally fine. It should be easy for you. Or even if you haven't had any experience in either R or Python. I started working on data using R. Master at Python. Okay. Uh-huh. Learned R first to do scientific stuff, to do research in bioinformatics, using R to analyze DNA, and further collaboration with doctors from Chulalongkorn hospitals, from Rama Tibbi hospitals, right? And but back then that was like 10, 12, 15 years ago. But afterward, I would say the beginning of big data eras, I use both R and Python interchangeably, or depending on the task. Right, sometimes actually using R is a little bit a lot easier, especially when we're talking about plotting a beautiful graph, creating visualization in the script. I think R is a lot better than Python, but well, this is subjective. In Python, actually, it has a lot of libraries that allow you to connect to the platforms, like connect to, say, JavaScript, connect to API server, which make it I think, practical in terms of usability, in terms of interoperability, right? In terms of working together with other components. For R, it's more or less standalone. Actually, it can integrate with a lot of visualization software, but in terms of integration with the systems, it's okay. But in terms of scalability, it's a little bit less functional comparing to Python. But both are fine, right? And you can use both to do big data. You can use both to do data science, and a lot of companies that I collaborated with use R and Python, right? Depending on where you work on, depending on the teams. I taught the course for Bank of Thailand to use R. I think 5 years ago, R tutorial and machine learning using R, and recently, right, using Python for Bank of Thailand, for all the commercial banks, for retails, for telecom. Yeah, so yeah, many of those. All right, let's begin and take a look at what R is and how easy it is. Maybe it will kind of convince you to switch from whatever you work on to use this one. Some of you may have asked why R. Actually, you can create a data model using Python, and it is a lot more popular nowadays. You will encounter Python and anyway, right? If you learn further in computer engineering, but the chance to learn another language like R is a little bit limited for you. So I think this would be a good chance to learn this, right? And you know a lot more languages. When I was in undergrad, I actually there was actually a course called Principle of Programming Languages. It is actually a quite good course to introduce you to multiple paradigm of computing, multiple paradigm of coding. Like you have functional programming, you have like the imperative programming, object-oriented programming, different type of programming in those courses, and you see more different perspective of coding. And nowadays it has actually advanced further to different languages that you see nowadays. You have like imperative languages like C, C++, the old languages, Java become OOP, Python becomes scripting language, crossing with OOP, crossing with like R that allow you to do things easily. You have language like Lisp and Scheme and Haskell that are very favorable in computing. You have JavaScript that you can use to create web application. You have a lot of language like Golang, I don't remember the name, Rust, and a lot of other that and like in blockchain like Solidity that you can those like types, another type of language that's actually based on the normal languages like Python functional types, and you can see that different types of language actually allow you to do different things, and learning one of them and choose only one is a little bit narrow-minded, because you can do a lot more with another type, and different properties from that. That's why you need to kind of diversify your understanding in programming language, and it kind of broaden your mind. When there is new language coming in, say Go, you can learn that easily because you already know that there are different types, right? So now, how many languages have you learned? You probably have learned, let's see, you should have known C already, right? C, C++, right? Java maybe a little bit later. Some you learn Python. Some you have seen something like in block language, right? Block language is a little bit, is also popular nowadays, right? You have like you can code block language in Minecraft. I taught it, learned it together with my son on that, using Lego to use those block language to do jobs as well. Okay, so enough about language learning. Today we are going to also take a look at another language, R, right? R, and how to use R. Basically, how to use R to do data preparation, to do data exploration. Right? Although we will look at exploration part later on in the course, like the next lecture. I think the subsequent 3 lectures, we are going to look at different types of usage of R to view data distributions, relationship associations, and something like network. Right? When you have multiple nodes connecting with one another, and then you want to analyze those network to gain more understanding. Okay, so let's start with the basic of R. Okay, what is R? R is a scripting language. Right? It's basically how it works. Like you create a script, and run the script, and then work as interpreter, right, line by line, and then run it on the R. You think about it as R virtual machine or the R core that has the basic computing that it will keep something like environment and how the each command should be interpreted, right? So basically the script to send those commands to that service, and then that service would keep in tab of the variables or environment that it has, and it would kind of translate the command that you send in into certain function. With those functions you manipulating, you are actually interacting with the environment variables with a lot of a lot of environments in that the service keep tab of. Okay, so that's actually to explain that, I probably need to go further to the separation between the scripting part. Right, you write a script, and then when you send the script into if it's C, you need to compile it into binary first, to object code, and run it, right? But in R and Python, there are something like, or in Java, so for example, you have like Java virtual machine. In Python, you actually have the basic Python program, and that you can run, and it would interpret the command into specific instructions. In R as well, you can provide the command line by line actually, and the software, the program will interpret the script into the command that it need to perform, and do that command, and that command will result in the change in the environments that you have. We will look at that later on when we look at the program. So R is a popular language that is used for data analysis. Right? You can use it to perform data manipulation, data preparation, and creating model from data. Right? It is actually originally originated from a language called S language, right, from Bell Lab, right, back then. Okay, let me change it to. How come this doesn't show up? Wait for me for a moment. There should be pointer. Okay, coming up. Okay, and that I think one of the good things that I like about R is that it has a lot of packages. Back then, I would say, because the growth of the two ecosystem, R and Python, there are like a lot of I would say both have grown their ecosystem quite a lot, but because Python has a lot of applications, has a lot of integration with, I would say, hardware side, so it kind of attract a lot more developers, and you see a lot of developments in Python, especially in the deep learning part, in the data science and integration with the big data part. That means Python nowadays contains lots of packages, but well, I would say 5 years, 10 years ago, if we talk about number of packages that you can use for data, I think win back then. But nowadays it kind of comparable between both. Right. So there are a lot of packages, particularly the packages that come from academic disciplines. Like you have a lot of package from scientists that deposit those packages. When they invented new algorithm, they would deposit that into the R repositories, and then you can download those packages to install on your computer by using a simple command like install packages, and then it will download that to your computer. Just like in Python, you have the pip command, and then you can install the package to your computer as well. So let's move on. This is a little bit old, but I want you to see the pace, the growth in this. This is the list of programming languages in 2016. Interactive top programming language. R is number 6. Python is number 1. Right now, for data science. Well, if you ask people in 2019 and now today, R and Python would be one of the two of the top, and also how to write the script to do the data preparation in database, right, using SQL languages. Okay, now you will learn this in database. You will learn this in data model, and Python, well, you will learn it anyway in other courses in FCP here. So why use R? Okay, you will use R usually because of it's free. It's easy to get the job done. There are just like Python. Right? It is clear, compact, and great support community. You can download a lot of packages to do necessary jobs here, and it is functional programming. What I like about R is a little bit of all of this, and another thing is that it is quite easy to read. Right, the code is a lot, actually I think a lot easy to read comparing to Python. Okay, so it's not when you learn R/Python, it's not like learning C and Java. R is dynamic typing. I know you don't have to declare variables. It is a functional. It uses lots of function to run code, and it is data oriented. So when you use R, usually use it for doing data analytics. Right? You wouldn't use R to do animation or to say write a software like that. It is more data oriented than say Python. Right? Python you can use it to control hardware. You can use it to write games. You know, to do lots of other things. Right? It has library and capability to do those. But for R, it is data oriented. Right? Use it for doing to build a model, doing an experiment, and you learn it through interactive explorations. Let's take a look at the software that we are going to use. This is RStudio. Suppose that you have already installed that into your computer. Right? RStudio is an IDE, right? The IDE for R. It allows you to do the syntax highlight. It has console. You can write script in here. You can see environment variable. You can see like the file, the plot, all in this software RStudio. This is the free software as well. And you can when you open RStudio, it looks like this. Right? It would have menu up here. It has environment variables and history of commands that you have ran before. It has this bunch of tabs that you can use to explore the file, the plot, the package that you want to install, and others here. And it has the console here. You can type the command in here, or you can open the script and it will be up here, and you can run the software there. So let me turn on this. Right. Okay. Right. This is the screen that you probably see first. It should look like this. And this is from the last year, I guess. Okay, here. Should have turned it on. Okay, right. You can actually create a project here as well. Right, creating a project here, meaning that you are creating the root part of the real project, which when you open the project, it will go into that directories, and also the file resource would be in that directory only. It will make it easier when you kind of move among computers that you use. Right. Enough about this. Let's try typing something into the console. Okay, and the new version contains this. It contains like the accessing to the terminal, showing you the current job is running, and the normal console. Okay, the version might be a little bit different between your computer and mine. I did not install a new version here, as you can see. Right, so try typing this command in into the console and tell me what are the functions of each of these commands. Okay, try that. 1 + 1, obviously, right? Obviously, It is string concatenation. No, different language. Obviously, this is the 1 plus 1, 2, right? If you open my script here, it will have the code afterward in case that you don't want to type and you want to just run it and see what happens. But I would recommend that muscle memory. Learning programming language partly is to type, to type in to learn that, okay, this is used, how this is used in this way, right? Running the script alone, although it's kind of okay, you will know how it works. I would leave this to well say later on when you want to review the code. Right now, let's take a look at what happened, because I can mistype and then it will show me, and there is also this nice context dependent menu that you can choose the function that you want to work with. Right? So mean, right? It tell you the help here. That okay, this is the mean function and generic function. That this is there is some meaning here. Generic function mean it is function that is able to apply to different objects. Right? That show you the arithmetic mean. You can also calculate the trim mean here. Right? For statistic, trim mean allow you to reduce outliers. Okay, if you want to know more, place F1. So I'll just place F1 here, and it will show help down here. This is what I like about R. It has built-in RStudio. It has built-in help. You don't need to type. You don't need to search for documentation elsewhere. It already has different documentation in this. Okay, generic function for trim arithmetic mean, right? You can use it like this. This S3 method. Definition mean x and trim equals 0. This is like standard parameters. And NARM remove NA equal false. So for this one, you can specify the fraction 0 to 0.5. This value, and then it will create a trim mean, right? A mean that trim top say 1% or bottom 1% out. If you use the value equals 0.01, right? 1% is, so the fraction is like 0 to 0.5 to the middle. Okay, and the value here indicates something like percentile. Do that. How can the help tab be open? Here. So say I type me mean, right? This, right? You can see that it say press F1 for additional help here. Press F1 for additional help. You want the help, you just press F1 and you hit that, you got this. Or if you specifically want the help for this one, I think this help. You can use the question mark and then type in the command that you want to show the help mean, and then it will show here. Or you can search here. Say I want to do the quantile. Here, quantile. Right, it will show you the documentation there. Why it doesn't work with ABS? ABS. ABS. I think because for ABS it has only well, you want because there's no context menu popping up. you need that pop-up menu. How to get that pop-up menu when you type less than 3 characters? ABS has just 3 characters. When you type ABS, it doesn't show up, right? But you can do this, type AB and then tab, and then now you have this context menu showing up by just doing the tab in the keyboard. It will show this, and then you can F1, or you can just see here, just read it. Okay, I understand how it works. You don't have to type it further, right? But you can well, you want to see further, just F1 here and show you here. And this is another thing that I like about R. That is the documentation are so nice. It has well structured documentations. You can see the descriptions here. Description. Well, let me use another one that is something like this. RPart. Oops, I need to load library first. Every library has to come with the documentation, right? It has to come with the well-formed documentation, and this is an example. You don't have to look at this now. I will load the library called RPart, which can allow you to use the decision tree in R, and then search for the help of RPart here. And this is what I want to point it out, right? You have this description, fit RPart model, a very simple function here, a very simple right function to create a model, and it contains this form of model. It has the argument explanation quite clearly. If you have like what are the possible values, and it has the details, how it works, how it is created, and it also has this reference which lead you to the paper that this implementation is based on. Okay, and it also lead you to other type of thing here. Okay, we will revisit this a lot in documentation, so please be familiar with that. All right, so try the other Unif, right? Unif. Oh, and another thing, let me show you this website. r.project.org. Okay. Okay, here r.project.org. Going to the CRAN. I think CRAN, right? Yeah, CRAN. CRAN is the Comprehensive Archive Network. Then you can go to packages, and you can see that there are 18,000 packages, libraries that you can use. I'm going to open this and go to RPart. Here. And what I want to show you is this, right? In the documentation, it has the vignettes here. What are these? These are documents that are related to the building of this library. If you click this, Introduction to RPart, it will show you the detail of how these libraries are built, like how decision tree work, notation, mathematical notation, the equations that it used to calculate entropy in the decision tree, the concept of entropy, the concept of Gini, and information gain that it is used, and so on. These are the mathematical concepts underlying that package, and also how to interpret the result of this. Think about this as user manual, as a book that explain how this work, because you can see this is like 60 pages. So instead of trying to search on the Medium, try to search Google on how to use these packages, you can just read this and then you understand the underlying concepts. And that I think most of the packages in R contain this type of documents, which will allow you to like pursue further on the topics that you are interested in. Okay. All right. Well, let us continue. Right? We use lots of time here. Okay, so you may have already seen how this works, right? You can just use this as a function. This is a type of function, and then you put the argument into the function, and it will return the results. And for example, something like this, the RUnif here. What does it? What are the function of RUnif? Clear screen. Here. Done. Every command that you type in will be in history. Okay. It'll be in history. Oh, there's this new one. Tutorial. Okay, never mind. Need to install another package. Okay, it will be here in the history, right? And you can save history as a script as well. All right. Let's continue. Oops. Let me answer this chat first. Department asked me something here. In the afternoon, it should be fine. Right. Okay. Let us continue on this concept. Right. You can see that this RUnif, right? What does it do? Right. Can you tell me? Type into the chat. What does RUnif do? It's not run if. It's not right. Run if something happens. No, this is R and Unif. R stand for this one. R stand for random, and uniform distribution. So what does it mean? It means that it will generate the uniform random variable RUnif. Right. Unif here. Provide information about uniform distribution, right? Min 0, max 1, and n here is the number of instance that you want. You can create like 100 of them, then you get a vector that is uniformly that were drawn from uniformly random distribution. Okay, when this is, you can see that it is very simple to generate the data like this, and there is actually a lot of distribution that you can use. Say we should go to RUnif first, and then type F1. Now you have this uniform distribution from the stat package. You can do the find the quantile given x, find probability given p, find the quantile value, or randomly generate the value. And there are actually author distribution that you can draw from, like hypergeometric, normal distribution, Poisson distributions, or Weibull distribution if you study about reliabilities. So there are different types of distribution that you can use to fit with the data, and we will learn this after the first evaluation. Okay, let's move on. I'm kind of slow here. So Unif 100, right? Mean function, you have already seen that mean function. That means the object created from RUnif will be used to calculate mean, and you get this 0.484, right? You may wonder, if you create something like this and it report here, how can you get the value? When you learn in C it doesn't have this concept, but when you call function like this and it returns the result, actually this result is stored somewhere, right? Oops. Never mind. I thought it has that. It's stored somewhere. But let's see where it is. No, I will look for that first. List of current object. I kind of because I wrote both R and Python. It's a little bit confusing for me sometimes. This is the list here. Global variable. Never mind. Okay. Never mind. Let's just move on. I will look for that later on. So when you use the function inside the function like this, the results of the first function will be used as input on another one. Okay, so this is like the when and the sequence that is run, it will run the script from the inside of the function and inside of the parentheses and then going out. So our Unif is just a random distributed number, right? Yes, right, it's just uniformly random distribution. How about the other? Right, this is 1 and comma and 10. This will create again another vector 1 comma and 10. This vector will be a sequence 1 to 10. Okay, this is 1 to 10. If you type in like 2 time 2 star 10, this will be 2 power of 10. And the ABS function will be the absolute. Okay, then and you can see that these are the basic functions that you have seen in I think a lot of languages. And for but the usage here, if you use Python, well, you may see that you need to use something like the name of the package that you import and dot and then the function here. But for R, is you can think about it as a bunch of functions that are combined together as packaged. So when you import package or when you use different package, you are actually importing those functions in. Okay, that means that there are chances that the function name will be the same, and you need to be careful about that. But for now, let's move on. In R, you can it is favorable to use this arrow symbol. It is arrow symbol to perform variable assignment. Okay, that means you are assigning this right with the name x. Okay, the command C1 2 4 would create a vector 1 2 and 4. Okay, and this vector will be assigned to a variable x. So now you have variable x that has a value of vector 1 2 and 4. Okay, if you type in C1 2 4, it will not assign to anything, but if you assign it to x, then you get here the object x. This is a numeric vector, has index 1 to 3. The value is 1 2 and 4. Okay, and you can actually use equal as well, but for me, instead using equal is usually preferable when you use this with parameters. But for assignment, R is preferred for the variable assignment like this. For example, Q here. Right, if you use Q and then assign C x and 8. This is the concatenation. Now we have Q, that is a concatenated version of 2x and value of 8 here. Okay. When you create this this new vector, it actually just copy the value from the old one, right? You are not really using x here. You use x as a to resolve the value as the object 1 2 4, object 1 2 4, and concatenate them. But these are not the actual reference to x. Okay, now let's take a look at how you can subsetting and then access the value inside. If you are from Python and C world, and you will be confused here a bit. R array start with index 1. Okay, so unlike C, unlike Java, unlike Python, R start is index with index 1, and the last index is n. So that's why I say that it is actually more intuitive for normal people than other languages. It starts with 1 to n. So you use actually the actual position, not like the 0 to n minus 1 in other languages. I saw lots of meme yeah, regarding this, because people in the Python world, in the C and Java world, really hate when the array start with 1. Like that's not actually shouldn't happen. But well, here it is. Right, start with 1 to n. Okay, so you can use this square bracket to access the value here 1, and this is like 1 to 4. You can put in vector inside this to subsetting the values. This is very nice here, because here you have q. Then if you put something like 2 to 5 here, what happens is that you are 2 to 5 would create an index 2, 3, 4, 5, and this index 2, 3, 4, 5 will then be used as argument in this square bracket, and then you are actually accessing the value at the index 2, 3, 4, 5. Okay, okay, right. That means you can subset it, right? This is like 1 to 4. Minus, okay, minus here is not like in Python. If you already know Python, put it aside. Minus in the subsetting here means remove. So you want q with minus 2 with the value at the second index remove. You can see that it is simple for normal people to understand, but if you already know Python, you see minus as something like this is supposed to be looking from the back to the beginning rather than the beginning to the back, right? This is like programmer thinking, right? But this means that you want q without. It is the same thing. It is the same thing. Subsetting value. You put in the values or the vectors into the square bracket. It means that you are going to subset it. But if you put in positive value, it means you are selecting the value. You put in negative value, it will remove those out. Okay, so here if you use something like q, and this is q, q minus 3, you have you have the 1, 2, and then 4 remove, because minus 3 is removed here. You can put in something like this as well, qc to 5, and then it will select just element 2 and element 5. You may wonder what happens if you put in something like this, right? You cannot mix them together, because the minus and plus sign here means selecting and deselecting. You cannot like combine them into the same argument, right? So this is how subsetting of the vector, right? We call this a vector of the variable work here. Okay. You will learn later on there are different types of data type here. There is a vector, a data frame, and others. Okay, and once you have a simple vector like that, you can now use function to compute and then store it into some variable like this one. This will calculate the mean of x and then store it in variable y, calculate the SD standard deviation of x, and store it in variable y1. Okay. Yeah. Y. Okay. Y mean of x, right? Y1 SD of x here, and you can observe up here that there are values, right, that store in variables. You can type y to access the value. I want to access the value. You can type. This is useful when creating a script. You can type the comment, right? The comment using hash function here. Hash, not function, hash sign here to denote that the rest are the function. The rest are the comments. Sorry. And the good thing about this is that when you run it, it wouldn't show, but it will show in the history that you run this as print out y. This is useful because it allows you to know that okay, you run this because of what, right? And it show in the history here, and then you know that it allows you to read the function easier when you look at the code. Okay. R also contains internal data that you can use for experiment. Now you can see the list of them by using the function data. Let's take a look. Here, data, and then empty parenthesis. Right, it will show you the data set. These are data set that you can access. Say you want to access the Titanic data, you can just type Titanic. Here to show you that it has this data set. Well, that means you don't need to, unlike say, unlike in Python, that you need to load it from elsewhere to do this. It is already built in. That means you can load it. Say Titanic. Actually, you can use data and Titanic, and then you have this promise that you use Titanic. And then if you type Titanic, it will show you this is a table. It contains this format, or if you type it's like iris, you can access the data frame. Let's load it. You can just use this and then assign it to author name here, df equal iris, and then you see that there is this data showing up here, and you can see the variables that it has. It has these factor variables and the num variables. Okay, and you can explore that by clicking this, and it will show you the spreadsheet version of data here. 4 column and 1 character column, right? 4 numerical, 1 character, and it looks like this in the environment view. Okay, so there are a lot of built-in data set that are interesting, but these are for learning. In your project, you should not use data from here. These are too easy. You can see that, for example, iris data contains only 150, or the empty cars data. These contain only, say, 32 observation, 11 variables, right? It is quite a small data set used for learning, basically. And from internal data set, you can do many other things, like Nice here contains the, I think the height of Nice River. And then we can use it to do the analysis, like histogram. Can create a basic histogram using hist function, and then NILE here. And then it will show you the histogram of the Nile River. If you want to know what the Nile River data is, you can type here. And then it will show you the flow of River Nile. Measure is, and or is it's not the height, it's the flow, right? The annual flow of the River Nile, time series of the length 100, and you can look at the reference here, time series analysis. Right? This is the data set, internal data set that you can access. You want help, and you can see that there are different types of way you can access help. Just type help, and using the you can type here as well, help, and 9, and it will show up there. You may wonder, can I use something like this? fine as well. You can see that they are very similar to one another between R and Python here. You can. This is the string object, and the string object which you can use here, or you can just type here, right? And then it will show you the help on the right hand side. Okay, let's move on to the next concept. This concept is the working directory. Right? You can when you work with the script, usually it will be stored on a certain path. Okay, if you want to change that home certain path to elsewhere, you need to change the working directory, right, to that location. Right? How do you set that working directory? Right? I actually has this instruction that you can do. You can go to there are many ways like this one. If you say you want to change working directory to this one, instead you can click on more and then set as working directory. This is the easiest way, I think. Or you can go doing the old way, going to session, and then there is set working directory here, and then choose directory to change the working directory. Okay, what does it do? Say if I to dir here, you can see that here I'm at the working directory as cp actually is at here our workspace, right? Even though I change it to cp213 and then lab lecture 2 like this, but you can see that if I were to dir to see the list of files in the current working directory, it show only this. Right, show only this files. But if I were to change here, set the working directory to this, it will set wd, right, and then using this path to refer to the location that I'm at here. And if I dir here at the console, and I will see that okay, the current directory has changed this one. So this is the command that you can use to the command that you can use to change directory, and you can see that you can do that in GUI as well, and then it will change it to here. But whatever, this would makes things easier if you want to interact with it. If you want to know more about these function and their family of function, you can just look at the help here, get and set working directory, and get wd, show you the current one. You want to use how you can get the path of the current directory, you can just look at here, right? There should be other file or other thing like list files and auto function file.info, file access, file choose, and many other. You can look at them and learn more about them later on by yourself, right? For now, let's try this. What I'm trying to do here is to show you another type of how you can access the file in another way. Here you can read the data from file using function read.csv. You type read.csv, and then type the CSV file that are in here, like flight CSV. You can use tab to help your life easier when you are in here, and then it will know that you need to input the path. So if you tab, and it will show the context file of files in the current directory. Then you can choose one way to do this in a simple way, or you can type F and then tab, and it will do the context filling for you. That okay, there is this flight CSV here. By reading the part here, right? And then if you were to just enter, it will read the flight CSV and report that okay, these are the data that it read, but it will not store in any object yet, because we have not assigned it to store in any object. So what I'm going to do is to assign it to an object. Say object name flight. Oh, okay. If you want to get the old command, you can just use the arrow sign up and down here. It will get the old command for you. read CSV flight data and assign it. Now we are going to have this flight data coming up here. You can see here is 300,000 observations. Imagine opening this in Excel. How slow would that be, right? And see how fast it is in R and actually in Python as well. Right? You can see how fast it is to load the data. And then you can do lots of things, which we will learn about it later, and it will also be your assignment as well. Say name flight data, show you the column names, and other function. We will learn about it later on. Okay. Right. Now we will learn the concept, and now you already see how the components of R. Like you can already see that you can type command in the you can type command in console. Oh, okay. And you can also do this by opening the script here. One session, you can run the command line by line. For example, this. If you look at the above, you can see that this is the run current line. This one is rerun the previous code region. And this one is source, is like running the whole file, right? Source is a function to run the whole file, which if you use it, it will run the whole file here. But to see how it's progressed, I'm going to clear the variable here first. Pop. Then you can click here, it will run line by line, and you can see the result and what happened in the environment line by line. Okay, from the script here, like that. Oops. Yeah. Right. Now, I have not created the oddcount.r yet. We are going to write our own function. You have seen how to write a simple basic script in R and run it line by line. Actually, if you want to run the whole file, this is the way to run the whole file. Source, and then the name of the file will run the whole file. Okay, and call it on console. You kind of call the function in the console. If you run it in the script there, it will run the whole file as well. But now we are going to create our own function, right? Because as in many programming languages, you need to learn the basic data type, which we have not learned that yet. Never mind, we'll learn about that later on. And how to use a simple assignment, how to manipulate it a little bit, and how to access files, which we will look at that in more detail later on. Now function, how to write functions. Okay, a lot of functionality in R comes from running the functions. Right? You kind of import the package to use those functions. Functions are a group of instructions that can take input, compute, produce output. Okay. Now we are going to create our own function. Let's see what are the format of those functions, how to write those functions. Okay. The way to create a function, you can type in the console, but I would not recommend that. We are going to create a new script. Right? Creating a new script, you can just go to the file and the new R script, and then type in the code here. And this code would count the odd number. Okay. If you can do better, you can actually do the function within one line. But never mind, I will just make it simple here. This is like assigning 0 to k, and then for n in x, right? For each n in x, it will go through each of the x here. If n mod 2 equal 1, then k equal k plus 1. Then the for loop continue and return k. That's actually a better way, right? Actually a lot simpler way to do this, but we will look at that later on. Okay. Just type it into the script and then save it as oddcount.r, and then we will load it up for me as well. So in order to create function, you need to have the keyword function. Function is another object in R. That means the function name will depend on the the assignment that will comes. Okay, I can create the function that just return 5, give 5, something like this. And then if I run this code, I will have the function down here called give 5. And if I run the give 5 function, it will return 5. So you can create functions to in different types, in different names. This is the name of the function, and then this is the function declaration, and the statement that come afterward would be the commands in those functions. So instead of having just one, I'm going to create a bracket here and then type in commands that I want this function to work, just like in C, right? And for this, I will also give the function an argument x. Right? X, you don't have to specify the types of x. Right? It is that dynamically typed, means that it can be any types depending on how you control, how you use it. Okay, so this I'm going to use this odd count, and then count the odd function, count the odd value. There are actually better way, right? Just sum of the odd function, but we'll do that later on. K equals 0 for n in x, and then another bracket to show you that, okay, if n mod 2 equal 1, actually you can type it in more well form here, k equal k plus 1. And then you can see that it also highlight the bracket for you, then return, return k. Done. Now we can save this function. I will save it as oddcount.r. If you go to file, you can see that there will be oddcount.r here. You don't have to open it because we already have here. What I'm going to do is to load the data in, like source oddcount.r. And you now have the oddcount function loading up in the environment, which you can use it, oddcount. And then put in some types of input, say 1 to 10. Then it will count that there are 5 numbers between 1 to 10 that are odd numbers. Okay. What else? Okay. How do we make this easier? Let me just comment it. Comment the code. How to make it easier? I can just use this. Return x, right? You want x because actually there is this property. Let's say 1 to 10. Mod 2. Well, it is, if you are in Python, this is called broadcasting. But in R, it's simple that when you have vector, any operation that performing with vector will be element by element. Well, that means I can use this x mod 2 and then sum them. That's it. This is the whole line of my function, just one line. Right? And then I can load the odd count again. And now the odd count would do the same thing. Right? Here. Oh, if you want to look at the code of the function, you can just click here. You will see the code. Okay, click here. Now you see the will odd count. It will show you the code of this function. Right. Okay. This is how function work in R. Actually, I spend lots of time here. I don't know. It is kind of very slow pace. Maybe we can go through this to the end. Can I? Let me check. Okay. Well, at least we can go it through until we cover all the different data types, and then we will take a break there. Okay, any question first before we look at different basic classes, basic data types, basic classes and data types in R? If you have any questions, feel free to drop it into the chat. Right, if not now, let's move on to, if you have, well, you can put into the chat the questions that you have anytime, right? Because it's better to ask than just to stay silent here. It's just typing anyway. Right? What is the difference between equal and assignment? This is a development of R for the mainstream. Actually, in the earlier version, you can only use the assignment symbol, the arrow sign, to assign variable. But later on, you can actually use equal to do the job. If you ask me what are the mechanical differences, I don't think I have enough insight in that. But I can show you this, that you can create something like this, 1 to 10. And then you have x equal 1 to 10 in the latter version, in order to, well, onboarding people from other environments. This will make a lot more easier to understand. But in the earlier version or in the old script, you can see that you can use it in this sense as well. And this is the original assignment notation that you use with R. But in the latter version, this is fine as well. X equal 1 to 10, something like that. So I would say that you can use either. No different here for now. But there might be a reason for that. Maybe you can find out that for me, right? On what are the difference between them. Oh, equal and assignment has there are explicit case that the equal and assignment need to be though. You cannot use assignment in parameter assignment. You must use only equal. Okay, there's a question here. I cannot find document that you showed previously. The one have mathematical for line model. Those are in the let me go to the site again. That project. It is here. If you want to access the package, just go to CRAN and select one of the mirror. And then from this, go to package. And then select the library that you want to access. Say sort by name, and what I'm going to access here might be something like clustering. Cluster. Something like this, alternating k-mean by cluster. And well, this is this one might not have that. See, for some developers, they might not deposit that documents, right? For this one, it's like version 01. But you have this from RStudio, which allow you to read the paper. RStudio review connection. You can look at that later on. Never mind. Let's look for another one. Maybe the old one would do. Part 1. Going to the package, and then in the vignette, and then you can look at this, and it will show you the document that you might want to read. These documents are very useful in understanding the underlying concept of the package. Okay, let's look for another function, say Twitter. Collecting Twitter data, right? RTweet, right? And here it show you how to obtain an access token, This reference manual will be a bunch of function that you can use. Intro to RTweet. Intro to RTweet would be something like this that you can run. You can also live streaming tweet. It is an example to do live stream. So you can see that there are different style of writing here, and maybe you will find it useful to do some other thing. I used it a lot back then to do bioinformatics stuff because it has like a lot of function and a lot of package that allow you to study bioinformatics, study like genome and other things here. Do the stat stuff like this, inferring directional conservative causal core gene network, like that. Right. Okay. Let's look at basic classes. Okay. R has basically 5, but actually I think it's quite there are quite development since I use R, so there might be more, but actually for beginner, let's say there are 5 first, but you may see that there are author as well later on, right? There are characters, number, integer, complex, and logical. Okay. And there are special type, special value like infinity, INF, and NaN, not number when you have like 0 divided by 0. You can just try typing it into the console, like INF will return INF, right? If you do 1 divided by 0, you get INF. Okay, that's you can see if you work in C, and it will just terminate and tell you that you divide by 0 something. And it's fine here. INF, you get infinity, NaN, you get NaN, which means you can have something. Sometimes you have like 0 divided by 0, get NaN, not a number. Or sometimes you import the missing data, and it will show you that this is not a number. Okay. There's NA as well. NA is not available, right? Missing data. It depends. It depends on when you import the data in, and then it might give you this NA, and then you need to clean it later on. Right, let's look at these different types. I'm not going to type here because just going through different types of data types. You have the basic type here, characters or strings. There's no one unlike C. In C you have like a character, and then you have string. For R you have this character CHR and string. Let's try that. Right, if I were to try x1, go hello world. Then you get this hello world type. Okay. If I create a vector, C hello, and then world, then you can see that x1 is a character vector. Right? It contains 2 string, a type of characters, but well, strings. It's a list. It's a vector of the character types, of the string types. Okay, for this one. This is real number. You can convert it into an integer. You can see that it's L, a long integer. Used to store this value. You can store a complex value here, 1 plus 1i. Then you get the complex value, and with this boolean, you get the boolean values. Okay, so these are all of them. Basic types. You will see it recurrently later on anyway. Let's move on. Now this is one of the most important concepts in learning R, is that you need to understand data structures of R. You have learned in your data structure course the concept of linked list, concept of queue, stack, and others. Those are very useful. I can tell you. Right? Those are very useful concepts. If you want to study further into, let's say, blockchain, into algorithmic design, into the development of algorithm for low resources, those are very useful concepts in data structure course. Right? For here, R also contains a number of data structure that are quite useful. We will look at that, like vector, matrix, arrays, list, data frame, and factor, which is a special types of data structure that was created in R, and later on, I think Python also copy concepts and then create their own Actually there are a lot of copy back and forth between these two environments. Right? Some of the packages you see in Python actually were copied from R. Some of the concept in R here were copied from Python, like equal sign, equal, anything like that. Okay, let's take a look. You can create a vector by just assigning. This is one element vector C and concatenate, and 2, 4, 6. And you get 3 element vector. This is one element vector. So every values in R is actually a vectors. Okay, this is like 1 element and 3 elements. Okay, you can add or delete vector elements by doing this. Okay, you cannot just attach additional element. Vectors are stored in contiguously in memory. It means that it kind of store consecutively in the memory side. You cannot delete part of it out. You can only create a new one that excluding the old one. That's why we have here x to 1 to 5, and then if you want to insert 0 in between, you need to create a new one and attaching the old 2 here and insert 0. If you want to delete, you need to just using the minus sign, then that is the delete elements, but you actually create a new one that not containing the old one, right? So it is also having a concept of immutable. You don't want to modify the object, you just want to create a new one, and then you can just discard the object later on. Say something like doing something like this. I have this x equal 1 to 11. Suppose that I want it to be just only 1 to 9, then I can use x and then minus 10, 1 to 10, say minus 11, and I just have this, and then I can assign it back to x, and here I already delete the old element here. And you may wonder, and what happened to the old objects, right? Because when you do this, you are essentially create a new object. What about the old object? The old object x, because by this you are creating the new object by removing the last part. What about the old one? The old one would be unreferenced, and once it is unreferenced, garbage collector would collect those unused resource and then return those memory to say the main pool. Then this is a process that it will be done automatically here in R. Okay, let's look at the command that you can work with this. Right, this is assignment. You can add, subtract value here. But if you do this, there will be a problem. Let me just use script. I don't want to slow you down here. So, oops, where are the operation down here? Okay, so I should mention a thing about matrix first. Then, okay, you can also, matrix is also a vector, right? Matrix is two-dimensional data type here. M is the matrix 2 by 2, 1, 2, 3, 4. You can create it by using this 1 to 4 and then say n row equal to, or n call, number of column or number of row equal to. You can look at the help by just click here and then type F1, and it will show you here the help of matrix. Matrix and n row equal 1, n call equal 1. You can change n row to 2, and then it has 2 row and then 2 columns are calculated automatically. Matrix is actually a vector because you can add matrix with vector. I just run it. You can see that now 1 to 4 is added with 10 to 13, right? And for the vectors, there are a bunch of operations that you can do. And now look at here. This is x is 1 to 4. I can add, I can subtract just one value, right? It would for subtracting 1 means that you are expanding 1 to be 1, 1, 1, and then subtract it out of x. Okay, same broadcasting concept as in Python. But the difference is this: in Python, it would not allow you to add the two vectors together when you have a mismatch, right? Mismatch size. Here, it will allow you to do that, but with warning. But you can see that from x is 1, 2, 4, when you add with 2 and 1, it will be 3 and 3, but how come the last one is 6? Because what it does would be, it would repeat this vector 2 and 1 again, so you have 2 and 1 and 2, right? So be careful about this, because in R you can add vector that has different size, okay? Because it will repeat the vector again, not fully though. Okay, you can multiply them, right, divide them, and doing modulo, right, like that. Okay, the missing data, right, missing data here is NA, right? If you put NA here, it will show as NA inside the vector. When you try to compute any vector that contain NA, it will return NA, unless you were to explicitly tell that NARM equal to. That means that NA will be removed. Like if you calculate mean, it will sum all the value and divide that by number of elements. If you have NA, it will return NA, right? Or you can use NA omit as a function to remove NA out, and it will remove NA out. Now this is one type of missing value. There is another type of missing, as I would say, it's a declaration called null, right? Null here is like null in C, but more flexible. Okay, you can create using null inside the vector, and then it wouldn't show anything. It's just null, right? Unlike NA show the value NA, right? For null is basically nothing, right? Nothing. And that means when this is created, it will just remove this part out, right? And 6 and 5 will be connected together. You get this vector. Now is useful for now to be used here. Like if you want to create an iterative function that would attach the value to certain variables, like this is z equal now, and then you what you did here is to create a for loop, like that if you have even number, then you would concatenate z with I, with the value here. So we just keep concatenating to z starting from now, starting from empty set, and you get this as the result. Right? So you can use now to initialize variable that to say that it's empty variable, and then create a script to modify that empty variable. Okay. Any question about data type before we move on further to author? Okay, let's finish this before we kind of wrap our head around vector. You can filter vector not just by selecting the position. Okay, I already showed you that. Okay, let's see what we have here. Q. I already showed you that you can subset in Q by, say, putting in some type of index, and then it will subtract. It will extract those elements out, right? But you can also do this. You can put in Boolean vectors. Right? Put in Boolean vector inside this to let it filter. Filter is not selecting, right? You create a criteria. You create a criterion or criteria that you want it. You want them to be combined and filter your vector like this. Say I have x to be 1 to 20. This is x. And then if I were to do this, x is more than 10. Then what I have here is the Boolean vector that compare x and 10. Then I can use this x more than 10 to subset x. Now I have x that are more than 10. Okay, you can see that they are quite flexible here. You can create a Boolean vector like x more than 10, and remember, write too many programs that I forgot how to. Yeah, and x is x more than 10 and x less than 15. You have 11, 12, 13, 15, 14, right? So this is how you can create a filters, right? By creating a vector of booleans and then put them into the vector. Then it will select part of that out. Okay. But if you just want to find the position, if you just want to find the position, then the which function can be used to find which position that satisfy this condition. Like, let me create it using Unif. 10 of them. Right, this is uniformly random value. X now is Unif. And what I'm going to do is to use which X more than 0.5. And it will tells me that the position 5, 9, and 10 have the values more than 0.5. Right? This is the which function. Okay. You notice that there are a lot of useful functions, but tell you the truth, I cannot teach you all this. If you learn this in Python, this might be something like argument, finding some type of argument, I guess. Well, I also write Python, but don't remember how. Though you have to look at the document. Okay, you can create metrics, which is basically a vector as well. Right, a matrix or two-dimensional array is a vector with metadata telling it that it has this number of rows and this number of columns. Okay, you can do matrix operation like multiply, add. Like this is matrix multiplication, which you remember, right? In your mathematics, if you multiply two matrix, the number of row or the number of column of the first has to equal the number of row. Matrix multiplication it's used a lot in algorithm, in data science, in data models, in machine learning, right? Because it reduces the dimension of your data to data set, right? To be just one. Okay. We will look at that later on. And you can do the arithmetic multiplication, adding two matrices together, like that. To index the matrix, you need to use this Z, right? And then it will kind of subsetting the row and the column. Let me go to this. Where it is, should be something here. Okay, this is M, creating M. What I'm going to look at here is this, right? It is 1 to 16, and it is Z. If you want to subset part of that, you can use this to subset the column, right? To the column number 2 and number 3. Column number 2, number 3. If you want to subset the row, let's say you want the third and the fourth row, or just the third row, then you get the third row out using this, right? Selecting only part of that out. You, as similar to vector, you cannot add or remove anything from C, but you can creating a new one. Right, you can create a new one that not containing the old one, like this one. You can use C bind. So instead of using just C, you can use C bind and R bind. These are the function that will buy data by row, like this C, and then we have C like this, and then we were to column bind 1, 2, 3. Oh, no, this is IP. This is 1, 3 times. You get 1, 3 times, right? Binding with the C. There is C bind and R bind. You can look at the function by yourself and try it later on. It's column bind, C bind and R bind, right? And you can look at examples down here. There should be a sample, or you can try it here. Examples. You can try it yourself. Okay. For vector and matrix, you can there's a concept of object coercion. This is important because many times when you read the data in as vectors, the data will be converted to be just one data types. Let's say if you have a vector of C of 5 and A, it will be converted to character vector of letter 5, string 5, and string A, right? This is called coercion, object coercion, right? If you have number and string, it will be coerced to string, to characters. If you have like numeric and boolean, then true will be converted to boolean. This will be C of true and 1 will convert true will be converted to 1 and 1. If you change it to false, or F is false, it will be 0 and 1. Okay. If you have character and anything, it will be converted to character. This is implicit coercion. For the explicit coercion, you can call function to do that. Like you have 0 to 6, you want to convert it into, say, character. Then you can use as.character to convert everything to character. Right? So this is the object called vector, which is the core module of R. The next one is like vector, but a little bit different. This is the object, the object called a list. Okay, a list here, like vector. Vector is like this. You have 1 to 6 like this, right? But for the list, you can think of vector as an atomic vector. That it has only one data type. For list is actually a recursive vector. That means you can store a lot of data type inside that. If you are familiar with JSON, list is like JSON object, right? You are creating something that can contain different types of data inside just one data type. Okay. Just like this. You can create list by using list and then attribute and the value, attribute and value, attribute and value, or key and value. Right? That's why you have this key, name, value show, key salary, value 55,000, key union equal true. And you can access the value inside by using $sign and the name of the index, or using double square bracket and then access it. Why using double square bracket? If you just use one square bracket, it means that you are accessing this list element. It will be list inside the list. You get the list. We will try that. Let's say the list object here. This is J, right? You can index it by using $sign, or if I were to use J here and then access it only, say, number 1, then I will end up with another list. If I assign it to X, then my X here will be another list of 1 instead of list of 3. Right? And then if I use X and 1 again, then I will still have list. It is like a recursive things. So if you want to access the value, you need to access it twice. And then you get the value of that position or of that name out like this. Okay, or you can just use $sign, which will allow you to access like the subset inside of this. That means you should not name your variables using any special type of character, right? One good thing about list is that it is dynamic. That means you can add element later, say J and location and Bangkok, and then it will add an attribute location here to J. That means it is not immutable. You can adding value in. So J and then $sign location. I will assign this to Bangkok. Then J would have the location Bangkok in here. Here, location Bangkok. And to delete the element from the list, you can just set that element to null. Okay, so J and $sign location, and set it to null. And now enter. And now let's look at J here. You can see that it already removed the location out because we set that to null. Okay, this is the list. I know that it's a little bit rushed, but well, say that this is like the review of the concepts. You learn about this more when you use it further. Okay, now let's look at like an enhanced version of the list, which is called data frame. Data frame is a table. Okay, it is very intuitive data types. Is actually a list that contains equal length vector, right? So we can create data frame by using the command data.frame and then put in the vector to vector in, and then you create a vector. And then we will see how you can import that as well. Okay, for the list, you can, before we move on, for the list, let me generate the list here. List of A, B, C. This is list C, A, B, C, and 1, 2. And then delete element of the list out. Finding the length, getting the name, change to change to uj here is actually just an array, a vector. Okay, data frame, you can import data frame from the data set. Like iris here is a data frame. Data part, you have iris as data frame here. You can look at data frame structure by using str, and then it will show you similar information as clicking here. And then you can access data frame just like in the list, right, using double square bracket or using the name. You can look at the data using head. It will return just only the first 6, right, and then add data frame in just like in the list. You can just use the name and of the new name that you want, and the old values that you want to assign in, and then you get additional column in the data frame. Okay, so data frame is like a table. Okay, that is how you can modify it. My example here, if you take a look at it here, you can create it by having 2 vectors and then combine them in the using data frame, and then first vector and second vector, which will create this out. And to access the value, right, you can. This is the same way that you can do as in the list, using $sign and the name of the column. str will give you this. str will give you the detail, the structure of the data frame. Head will give you the first 6 lines, and you can create like a new one by using the same way as a list. Just use $sign and the name. We'll create a new one. Deleting, setting it to null, and it will delete. Adding or combining, then it's just the same as in metrics. Right? There's R by and C by, but this is one way. Use R by and then convert this to list of the empty card, and it will bind together. Or you can also use this function. This is how you bind the vector and the data set together. You can use R by data frame. Right? R by data frame allow you to bind, because R by here you need to have a list and a list, the same thing together. R by data frame allow you to bind the data frame with the vector, like this, which will bind data frame with vector, and you have the last line here, binding in row. Okay, so rbind produce a new data frame that binding the old one and whatever you want to bind with. This is the data frame. Basically, it is a table, right? And then for a table, think about the table. In Excel, you can delete the column, you can add the column, you can attach it with another thing. What else? You can just that. Right? You can access the value of the column by using this. Let's look at this one, the iris, right? If you want to access, say, the species column, then you can use iris $ species. It will return the species column. And one interesting thing about this species column is that it is not character, but it is the thing that is called factor. Interesting, right? There's factor with 3 levels. That means it has 3 levels. It has 3 levels. For this one. It has 3 levels, right? Setosa, versicolor, and Virginica. And the value here is actually 1, 1, 1, 1. It's stored as numbers, What is this? This is a type of variables that that is very useful. It is a type of variable that store the value that are categorical, right? Not the actual text, but the categories. And by storing it as category, it actually save a lot of memories in storing data because it can store it as integer. And then 1, 2, and 3 would denote, say, rent, mortgage, and own. Right? It can denote the level. Okay. You can create factor by yourself using a function called factor, and then it will generate this factor for you. I have example here. You can use it with whatever type that you want. Let's say this is a number. You can even convert it to factor, and then you have 5, 12, 13, 12 as factor, and then 5 is the factor. 12 now becomes factor, not values, and 13 also become factor, become the level in the factors. Okay, if you were to str and then xf here, xf, then you see that it's actually store the character 5, 12, and 13 as a factor, and the value that is actually stored is 1, 2, 3, and 2. Okay, so it treats this as a nominal, right? A nominal data that you learn in the statistics or the category data, and these factors are useful in statistical model, and that we will see it later on. All right. Read CSV file. I already put it here. You can read the CSV file as well, and providing it with different separator to see more. Type F1 here, and then you see data input, and this is read table, read CSV. Okay, you can specify the separator here because HR employee addition use semicolon as separator. You need to use specify semicolon here, and then once you run it, it will return the result here. But I don't really remember if it's semicolon or not. Let me open the file to see if that is the case. Here, sorry, it's actually comma, but you can specify other types of to the way to import the data in, right? Like actually separator should be comma. If you specify it incorrectly, you will see that it kind of return just a one character type here, which will be incorrect. Say if you were to store it as x, then you see that x here is one variable, right? One variable which is wrong, right? It's actually many variable. You just use this. I think you can run the line by using Control Enter. It will run the line. Okay. Let's say if I were to assign it to x, Control Enter, then I will get x here with 35 variables. And the read, you can see that the variable here would automatically interpret that which one should be character, which one should be integer. If you want to force it to be just one type, you need to look at this. There will be argument that allow you to define the data type. But well, I will leave that to your research here on how to do that. Okay, so that is how you can use R, the basic R. Okay. Now let's take a break. Right? Let's take 15 minutes break, and after the break we will look at how to use R to perform data preparation using library, how to import library in R to help us exploring data, to help us preparing data. Okay. And during the break or for the earlier section, you can put in the questions that you have. Think about them. What are the questions that you have about that? Or if you don't have any, maybe some comments about the earlier section on what you think about R. And then we will continue data preparation after the break. We will break until 10:50, right? See you in 15 minutes. Okay, let's continue. Right, now we are going to look at how you can import the data into R and then perform certain types of data preparation to prepare data into format that you will want. Right. Okay, and what and the libraries that we are going to use are called tidyr and deplyr. These are part of the I would say the larger library called tidyverse that allow you to change the data into what they are called tidy data, right? What I would usually call the analytic based table or customer single view, right? What I am referring to is that when you prepare data, you should prepare data so that your data is in terms, finally your data is in one column. And that one column here, the package referred to as tidy data. This data should have variable of each variable has its own representation in columns, and each row contains the observation or contains the unit of analysis that you want. Okay, think about this. Suppose we are to prepare this data into student data, where I would want each row here to be each student. Okay, I want each row here to be each student. If I were to create a model for say customer in the company, then I would want each row here to be customer. If I want to create a model for each stores, say the company has 4,000 clients, then each of these should be the stores. Okay, and then the variable would be variable associated to that stores. Okay, so this data type, this data format will be used in a lot of model that we will see later on. Okay, just remember that this is called, for me I would call it customer. If we are talking about customer, I should use iPad. Never mind. Writing with this is hard with mouse. Single view. Or here maybe another name here should be called analytic based table. I think that's a better way. Use this instead. Analytic based table or the customer single view if we are talking about the single view, the view of the customer. Right, and but here for this package it refers to tidy data, right? So different names, but it means the same thing, right? And there are concepts that I want you to know. The unit of analysis. Right? What is unit of analysis? Unit of analysis is the unit of which that model will represent. Right? It will be the thing that you want to represent in the data, depending on the question, depending on the problem that you want to solve, right? So let's continue. Tidy data. Each column refers to each variables. Each row refers to observations, and one table has one types of observations. Like if I were to use it to represent students, then this table should contain student data, nothing else, right? Each row should be representation about, each row should be each student, each column should be variables about students. It can be aggregated from a larger perspective, but it has to be about students. Okay, let's try this, right? Load the data r-dataprep.rdata. You can type in this script, or you can just go to file and then you will see that there's that r-dataprep here. You can just click here. I will clear it first. I will clear the workspace first so that we will have like clean workspace. Then I will click the rprep to-dataprep.rdata. If you ask me, do you want to load rdata file here? Click yes. Then it will load here for data frame, cases, pollution, storms, TB. If you type cases, then you see that it's just a small data set cases with this format. And storm, right? Just a simple data frame for easy to understand. So our idea is that we want the data to be in the storm here, storm form, in the form like we have each columns contain variable and each row here contains each storm for this one. But well, each of these contain the unit of analysis that we want. But we can see that the two on the right are not really in that yet. This one has country on each row, but it also has years on the column. This format is called the cross tabulation. It's often found in data related to report, right, that built for human to look at. You have one variable in row and one variable in columns. The other side here, the other one here, the pollutions. This contains, suppose that you want to have variable about just cities, but it contains, well, multiple cities for each row. Well, not, it contains one city for each row, but the city can be repeated. You need to have pivot it up, right, to have these two as separate variables. How do we do that? We look at that here. Okay. You can look at the whole. There is a cheat sheet here. You can click on the link and then it will lead you to the cheat sheet, which contains a lot of summary of the functions that you need to know. You can try it out and then maybe try it as a tutorial on your own on what are the functions of each of this. In summary, these functions would relate to the tasks in data preparation, which are: you need to reshape the data frame. You need to reshape them into a certain structure, right? Which can be done by reshaping table using gather spread. Actually, the name is changed, I think, to pivot wider, pivot. And let's look at that. But there, like, the name changed a bit here. Let me check. I need to load library first. Library tidyverse. And then look at the help. Actually, it's changed to pivot wider and pivot longer. Right, pivot wider. It would here widen the data. The old name here is I think the old name that I use is spread. Here, spread key value pair across multiple columns. The life cycle of this function is retired. It now changed to pivot wider, but it can do the same thing, more or less. So you can use like pivot wider and pivot longer, gather spread. You can reshape column to multiple column or combine them. This is unite separate. Then you can subset them in row and column, which you have function called filters, distinct, sample. These are the function that would modify the row, number of row. And you can use select to select subset of the column, which is select. And then you can summarize them, group by summarize. This works like in SQL that you have group by and then you have aggregate function. Right? Group by summarize work similarly in Python as well. And you can create a new variable using mutate and using left and right join, inner join, joining function and binding function as well, and union functions. Let's look at how it works. I'm going to follow through with this. It's on the second session. Okay. As I already loaded here as well. You can use gather. This is the old form. It's still working. Or this is changing to pivot. Gather is mean that you gather columns so it become pivot longer. And then you need data, it's cases, and the column that you want to gather, years, n. Oh, this is a new name. I should look at this because it's changed the format a bit. It has the data column name to here. So the way to use it is to use pivot longer, and the column name, the column and the name too. So I want column 2 to 4. Here it will combine it to 2 to 4 down here, but this is for the cases data, but it's still name and value. If I want it to be specific names, you have used name 2, and then this change to year and end. Oh, not name 2s. Oh, you don't use name 2s. I need to use name sep and name pattern. Well, let's see. Name 2 and value 2. To use name 2, multiple name 2, you must also supply name separator or name pattern. Accept. No. Years and no, because I did it in the old version, this scatter. I think I'll leave it to you to figure out a new version. Case, years, and no, I'm not going to use this. So you can see here that gather the column down and then change the name to years and end. For pivot longer, I think I will leave that to you to figure out how it works. Right, and probably need to switch it a bit from the index, from the name into like the new name that you want to put in. Right. Another one, spread. This is gather, right? Gather from multiple columns to 2 columns. 2 columns. Spread, and you need to specify the column that you want to be key and the column that you want to be value. So here is spread. And the new function is pivot wider. I think this should be simple for this one. Pivot wider. You need data, pollution. You need ID call, name from, value from. ID call is the city. Name from is the size, and value from come from amount. I can type it like this. Should make it readable, more readable here. Let's run it and done. Like that, and you can see that using tidyr deploy r, you don't really need to put in the quote into the column name. It refers to the column name directly because you call it inside the function here. Right. So this is similar to spread, and there's this function separate, which just separate the column into multiple columns. Just specify the separator. It says unite, which will unite multiple column into 1 column. You can see that each of the function in deploy r, in tidyr and deploy r, work like this. You need to specify the data frame, and then you have a bunch of parameters that you can specify to do this job. Now, the good thing about this is that you can combine them into workflow, right? So that it will just work from the source and then go through to the end. Right? But we will look at each of the functionality of the component first. Okay. Next, we will look at different way that you can extract variable, extract observations, create new variable, and change the unit of analysis, like summarize and group by. All right. I'm going to just follow through with the tutorial that I have here. So you have already seen this. This is separate. You can separate the column into multiple columns. You can see that year, month, date are separated from just day, or just date, and you can unite them, right? Combine them into just one column. Right? Combine them. Can combine column. I probably need to assign storm 2 first. Storm 1 and storm 2. Can subset column that exists. Storm 2. Storm 2 has year, month, and date on each of these. So unite function, combine multiple function. You need data frame and the column, new column that you want. Let's look at this here. New column and the range of column that you want to combine. How come it say that it doesn't find that year, month, and date? Probably this. Yeah, and now you have the new data here, new column here that combine with all of that. You can see that these 4 will change the structure, right? Like from the row from one type into another type, and also you can see that it changed structure in column wise in the entire table, right? Now we will look at the function that allow you to do different things, starting from select column. You can select column by using just the data frame and the name that you want to select. So select storm and storm pressure will select 2 column out. Select storm and minus storm will just deselect that name, deselect the name storm out. And if you use the range wind to date, then you can select from wind to date. Right? You can use range to selection. This is the selection of the row selection. And actually there are functions that allow you to help you to do the job, like you can use this range to select in range. You can use this contains or end with or big or start with to help you select in the columns. For example, I can use select with iris, and then iris has the sepal length and sepal name, and then I can use the function called start with, and then put in the name that I want to match sepal. Then it will select only 2 columns. Maybe I should use this as well. Head. And here you can see that it select only sepal length and sepal width, and return it as a result. That will be a better way to write this script rather than just putting it in like multiple parentheses as function. There is a better way to create a workflow, which we will see about that later. That means for select, you can use function here to help selection, not just the name, but all of these functions would work. Like you can write Lagrange expression using matches. You can use num range. You can use end with, start with. You can use contains to select the subset of variable, which is a lot easier comparing to say SQL, right, for variable selection. Right. The next we will look at selecting rows. Selecting row can be done similar way to vector. That is, you create a condition and then put into this. Then it will filter data frame with this condition. You can create multiple condition, and then it will filter with multiple condition, as simple as that. So here I have the data storms. Data storms look like this. You have wind speed, pressure, and date. Then I will filter storm with wind more than or equal to 50, which should result in Alison and Alberto, right? and also Aline. Here you have the result. You can provide multiple condition by using comma here. This storms in, right? This set just Alberto, Alex, and Alison. So it will kind of find the condition that the results here would be in this set, and then you get the result, final result here. logical operators. From this, you can see as well that there are a bunch of logical operators in R, like more like greater than, less than, or in group membership, or is equal to NA or not, like that. Now you can select columns, select rows. Don't worry if you are not being familiar with it now, because I will have the lab assignment that you have to do it on your own at home. To do this work, you need to use a bunch of these to understand them, right? So you have chance to practice afterward. Mutate. Mutation means adding column. You are adding columns. Here, ratio would equals pressure and wind, and inverse would be ratio inverse, right? Ratio to the -1. Right? And you can see that you can create new column just using mutate here. You don't have to use $, whatever. But here, the data frame and the thing that you want to create in mutate. That's it. You have here, you have new columns that can be used. Now, you can, these are the mutate functions that are available. You can use it to do percentile, cumulative mean, and others. Like if you use cumulative sum, then it will calculate the cumulative sum starting from 1, 2, 3, 4, 5, 6, and then you have cumulative sum. 1 plus 2 equals 3, 3 plus 3 equals 6, 6 plus 4 equals 10, and so on and so forth. Right. Now let's look at summary. Summarize. Summarize is a function that allows you to reduce the data, allows you to aggregate the data. And this is the new way that you can write, instead of writing function name, data frame, and parameters, right? You can rearrange it into this format. That is, you have data frame first, and then this is called a pipe. A pipe would put, this would put the, let me change it to here, right? It will put the data frame into the first position automatically, right? This is the meaning of this pipe, which makes, although it's a little bit trivial, but you can see that it will make reading of the script a lot easier, because this is like, okay, you start with pollution, and then you send this pollution to function summarize. This function summarize will calculate median, store it in the variable median, calculate variance, store it in the variable variance. Right. This function summarized will then, okay, for this one, it will also calculate n, which count the number of rows, n here. And there are like a bunch of functions that you can use in aggregation: mean, max, sum, median, variance, and even your own writing function, your function that you write. Basically, this function has to combine a vector and generate just one result. Okay, let's take a look at that. Here we have pollution. And you can use summarize this way, and then it will summarize it to just median variance. Or you can do this in this format, which also work the same way, right? Except that it is easier to read. Okay. You can also sort data frame using arrange. Arrange will sort data frame based on variable that you specify. Like this one, it will sort wind. Okay. If you want it to be descending, then you need to use descending and then wind. Then it will sort the table according to the wind column, descendingly. Okay. This is the arrange function. Here you can see that it's sort descending order. You can also use the like sorting two variables, sorting by wind first, then sorting by date. And you can see that here it's sort by wind first, and then 45 and 45, because you force it to sort by date. That means the date that comes earlier would come first. Okay. Next is the one that I already mentioned, the pipe operator. What pipe operator does is to put data frame here into the first location. That means instead of writing the script like this, select storm pressure, you can do it like this: storm and pipe, select storm pressure. Why doing this? Because it makes the life easier. Because for example, you want to select and then filter, you can just add pipe at the end and then say storm filter first, win more than or equal 50, and then pipe and then select, and now you have like a workflow. You can create a workflow that's starting from the first data frame, then it work one by one, command by command, until the end that you have this result here. So storm and storm pressure like this, right? You can chain it into pipe to do this, and then instead of filter like this, you might want to use the result later on. You can use pipe and then using select after filter, right? And you can use mutate and then select here, mutate and select, and then assign, right? You can use this. You asked me, right? You asked me first, what are the difference between equal and the symbol like this? Because when we use the arrow, we mean to assign to some value. The developer of this tidyverse, tidyr and deployr, they come up with you can do the right assignment, right? Because you now put the storm into mutate and select, and the result, if we were to just do this, then you get this. If you want to store this result into a variable, you don't have to go into the beginning. You can use this right assignment to say that, pointing that this will be stored at storm ratio. And now we have the storm ratio as a data frame, right? This is simpler to read because you start with data frame, you end it with data frame, right? And then it's a lot easier there. Okay. Okay, I think it's almost done. I'm almost done here. There are functions like by columns, which will combine like two data frame together, and by row, which will kind of attach it to one another. I'm not going to kind of repeat it all one by one here, just to overview that it can be done this way, which you need to be familiar with it by practicing in the lab and look at the help, the documentation, which will help you familiar with that. Okay, I think this is the last function that we'll look at. It is called a group by function. Group by function will create a group, and then when you use it together with summarize, it will summarize for each group. You will learn this in database as well, that there is group by. You learn it in Python, that there is group by. Group by work the same way, that it is create a group, and then from that group you can create an aggregation of the group. For example, this one, I can do this pollution data set and then group by city. So it will group by city like the colors here. And then you can call summarize. To summarize, create a mean. It will create a mean of each city, right, based on the amount. Just like that. So here, if you just group by city, then it will say that, okay, this is the data that has the group of city, but haven't done any calculation yet. But if you pipe and summarize, then it will perform summarization. Here, calculate medians, variance, and n. Right? Okay. These are in the script. There are this. You can do the set operation. Like you have the y and z like that. Sorry, y and z like this. You can do the set operation. You can do binding, right? Binding them together, and you can do the union, which will union the result. Right? You have like A, B, and C, D union together. So if the values repeat, it will have only one value. You can do intersection and find set difference. Right, so this is like set operation, and these are the database operation that you can do is left join, inner join, semi join, and anti join. Right, you will learn this database operation again in database class, but let me explain this in a simple term. Left join. Right, you have the data set here, the data frame table. Song and name, and you have this artist. You want the information of the right hand side to be attached to the first one. Right? So in order to call the function to do this, there is a function left join, and the first table, the second table, and by here would specify the key, right? The key that you want to join both together. The result would be the left table with the columns of the right table. This is left join. Okay, let's look at this. This is left join. So left join would produce this Pekisu body and play what don't know because it's not in the artist database. Inner join will result in only those that are matched between the two tables, right? Semi-join, right? This is semi-join. Semi-join acts like join, but it's not actually join. It's actually a filter the first column. And anti-join will result in only the one that are not matched between the two. You learn this in database course, right? Different types of join that you can do, but you can see that here there's functionalities that can be done in R, right? Okay, now actually this is all of today's content. Now these are the labs. In this lab, you need to load the two data frames, flights.csv and airlines.csv. Write an R script to load the two data frames. And then it needs to perform these. First, it needs to select two columns, carrier and departure delay. Then it needs to filter out NA. And then you need to use carrier as a group and calculate the mean of departure delay. Then sort the mean of departure delay, sort by the mean of departure delay, sort worst carrier by the mean of departure delay, and then join in the name of the airline using the airlines, the file here, using carrier as a key, and show the result. This is the expected result, mean delay. You should have something that looks like this, right? For that. Okay, so what you need to do is to write an R script, and then write an R script and then run it, and then show me just screen capture, whatever. You can just select the code, put it in Word, Microsoft Word, and then save it as PDF and upload to LEB2. Right? You need to upload it as PDF to LEB2, otherwise I wouldn't know. Right? And also don't forget to show this expected result. Okay, that's all. Right? I know that is a lot to learn language in one day. Some of you may have just seen this the first time and may have been confused right now. My suggestion is that don't be, just learn, just try it line by line and then try to understand it, play with it, right? Play with it a lot and then you gain skills, just like when you play games. You play games to gain experience in games. When you playing with programming here, you gain experience in life, right? In your own character, you get experience point coming up. Then you can use those experience point to upgrade the skill. Yeah, you got data preparation skill, like that. Upgrade the skill in the skill trees. But that's your own character, your own skill tree. So hope you spend resources to improve your skill here. Right? Any question that you want to ask? I will try to be faster in terms of uploading the video. Though I got lots of stuff that need to be done. Yeah, I promise that will be faster for sure. Any question? You should upload PDF of the result and the code to LEB2. I don't have CPU213 in LEB. Yes, I have to create it first. Then I still have not created CPU213 stop on LEB2. We'll do that. Never mind. Yeah, it's my fault. Yeah, I will do that later today. All right. So you can upload your work there once it's done. Okay. Practice with this. It should enlighten something. The deadline, right? The deadline is before our next class. Okay, so you can do it today, you can do it next in this Friday, Saturday, whatever, right? So you have until the next class to submit the lab. Capture the result one by one for each step when the work is finished? No, you can just copy the code, the whole thing, and then capture the result. Just that. Why is that? Because each of these can be, actually you can do just one line of code with to do all these things using pipe. You can use pipe to do all these line of codes. I say 3 lines, like one to load the 2 lines to load data, and then 1 line to do the whole thing here. Right? You can do that if you use pipe. Okay. Oh, there's a trick here that I think you should note. Say here, I'm going to use the flight data. Do I have that? Maybe not. No, I have not loaded the flight data. Let's see. What do I have? I have TB data. Okay, the TB data here. You can do this. Okay, I need to remove NA, right? I can use pipe, and then what I want is to remove NA, right? NA, but in deploy R, these, you can see that these are not in deploy R. These are NA if and author. You want to know in deploy R. This is a deploy R. You want to know the function in deploy R that help you in this. So you can search how to manipulate NA. Yeah, let me do this. In deploy R. Okay, I can do this na.omit. No, for this one, you can see that, okay, NA here probably should be filled with 0 because it means that there's no counting here. So I will fill NA with 0. Let's drop NA. There's this function called replace NA. I replace NA with 0. And then if I run this, replace NA data frame. It's pipe. It's list. Oh, say, okay. List, and then I need to look at TB. The child was 0, and then adult equals 0, and elderly equals 0. Now I have already replaced all of this with 0. Then I can then pipe and then do the sum, mutate, right? Number of cases. Cases equal child plus adult plus elderly. Now I have another column called cases. And because I will not use child or elderly anymore, I'm going to just drop them, which means that I'm going to select and then minus child, minus adult, minus elderly. You can see that you can do this step by step. You can do this step by step, and then okay, now you have like 100 years, text and cases. And what I'm going to do is to maybe pivot wider, and then use country, pivot wider, ID column, ID column here will be country and year. Oh no, country and sex. And names from this one, I'm going to choose the year. And value from will be from cases. Now here, I will have this cross tabulation, nice cross tabulation, with the first column as country, second column as sex, and then the remaining column would be years, starting from the first one to the last one that I have here, and that would be like more until 2013. Okay, so this is how you can write it in just one command, and I can even store this if the results look satisfactory. Then I store it as result. Then once I run this script, I will end up with the result here as a data frame, right? And I actually there is even more. Like I can use write CSV, and then say to file result.csv. Thai assignment is panel language. Oh, no. Okay, it should be pipe. Oh, there is a faster way that you can, instead of type percent, more than percent, there is a faster way to type this pipe by using Control-Shift-M, right? Control-Shift-M, and then it will do this for you. Right, CSV, and once you run this, now you have the result. Result.csv. You see that here, right? You can even replace TB with read, right? It will read and then write and do the thing without even have to have another. This is one line, right? Although you see like 8 lines, that is actually one set of commands starting from the first to the last. So you ask me if you have to catch it one by one. No, you can copy the code and put it there, and then the result as well. Okay. The thing is, copy from your friends will not improve your skill. Okay, and I can guarantee that you will not understand anything if you copy from your friends. You are because I think most of you play games, right? In order to gain skill, you need to gain something like experience, right? You need to do things to gain experience, to gain skills, right? If you copy from your friends, the skill that you will gain is copying, not writing program. Okay, and you will think whatever you can handle it out, but I would say that this is just a chance to learn, and it's not difficult, right? So do it your own, right? It's not that difficult. You use just like 5 minutes to 10 minutes to complete this once you understand that. And if you practice with this a lot, it will be like the tools that allow you to gain 100,000 baht per month with data science skill, right? Copying would give you zero, wouldn't give you things about understanding on this stuff, on the concepts here, right? So don't copy. It's easy to copy and then upload to the systems. And frankly, I cannot check actually, because it will be difficult to check whether it's because it's so simple that it can be similar. I cannot check. So it now left is depends on your honesty to just do the work, gain the skill. This is a chance to gain skill, and then submit the work as part of that, right? So hand the work in before next time, right? I will create the LAB2 stuff for you to submit the work to. Don't forget to save it as PDF. I don't like to open Word file. It can contain virus, so I don't like that. So save it as PDF and submit it to LAB2. Right? Any more questions that you like to ask? When you see me look at this, actually I'm looking at the chat, and look at it, this is actually the screen for the code and other things. Okay, if not, then goodbye. Then see you next time. Oh, and there's a question here. Please explain about pipe again. Okay, sure. Pipe. So you can write a code like this. Select TB data frame, like, and then condition that you want to select. But you can also do this. Put the data frame first, and then use pipe, and then functions that are in deploy R, that are in tidyr, deploy R, tidyverse. You can put it after the pipe. What it does would be that it would put the data frame that you have in as a result here into the first argument, right? You may notice that every function that that this library used always start the first one with data frame, and with pipe here it will put the data frame into the first argument, and which will make it like this, that you put it in the first argument. That means you don't really need to write it in this way, right? You can write it as a workflow, because here I can write it as a workflow that starting from this data frame, I'm going to replace NA and pipe, and then I'm going to mutate, create new column, and then I'm going to select the data and then do this, and then finally this also supports the saving as well, because write_csv, write_csv come from deploy R. Okay, so that's how the pipe work. The percent, and then more than percent, more than sign, and percent means it's called a pipe, right? It helps you able to read the code in a simpler way, I think. Okay, if you have any more questions, feel free to post them into the group. Right? I will answer this. I will answer them as soon as I saw it. As soon as I saw it and I have time to answer them. And I will upload the video probably in 2 days. Let me have time to work on that first. Right? So have a good day then. See you again next time on next Monday. Bye everyone. I should end it like signing off. Peace.